Okay, in this video we're going to talk about critical numbers. Critical numbers are something that is going to be very important as we continue on in this unit. So, a critical number of a function f is a number c in the domain of f such that either f prime of c is equal to 0 or f prime of c does not exist. The second part of this is something that people always forget when it comes to finding critical numbers. So what we're going to do is we are going to take the derivative of the function, and then we are going to look for when is that derivative equal to 0 or when does it not exist. And whatever those x values are where those things occur, those are what we call our critical numbers. So this is to take the derivative. So f prime of x is going to be 3x squared plus 2x minus 1. Because the derivative is a polynomial, I don't have to worry about this second part of this, because a polynomial will exist everywhere, so I don't have to worry about finding x values where this does not exist. To find the critical numbers of this function, I'm just going to take my derivative and set it equal to 0. So I'm just going to set this equal to 0 and solve. It does factor into 3x minus 1 and x plus 1. And I set those equal to 0, which means our critical numbers will occur at x equals 1/3 and at x equals negative 1. Those are our critical numbers. Number 2, find the critical numbers of this function. Again, your first step is always find the derivative. Sometimes people make the mistake of just jumping right in and setting things equal to 0. Remember, find the derivative first, and the derivative is what you set equal to 0. So we have a quotient here, so I am going to use the quotient rule to find my derivative. So I'm going to do the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. I'm going to simplify this a little bit. So we've got 4x squared minus, if I go ahead and distribute my 2 here and then also distribute my negative in front, that's going to be minus 2x squared minus 2, and then over 4x squared. So we have 2x squared minus 2 over 4x squared. Now, if your derivative is a rational function, it's going to be equal to 0 when the top is equal to 0. So we're going to take the top and set that equal to 0, and that's going to give us the critical numbers where the derivative was equal to 0. So that's going to occur 2x squared minus 2 equals 0. So if I add 2 and then divide by 2, that's going to give me x squared is equal to 1. Which means we get x equals positive and negative 1. Those are going to be 2 of my critical numbers. From a rational function, if the bottom of the rational function is equal to 0, that's when it's going to be undefined. So I'm going to have my critical numbers where the derivative is undefined when the bottom equals 0. So I also need to take the 4x squared and set that equal to 0, and that is going to give me an answer of 0, which is another critical number. It's just a critical number where the function is undefined. Okay, so take the derivative and then set it equal to 0 or find where it's undefined. That is how you find critical numbers. A little caveat here. If f has a local maximum or minimum at c, then c is a critical number. So if you think about taking the derivative and setting it equal to 0, you're finding when we have horizontal tangent lines, and that is occurring at our local maximum and minimum. So a lot of times when we find critical numbers, it's going to help us to locate the coordinates of our local max or local min from our graph.